So, hello everyone. In today's session, I am going to discuss the concept of fuzzy set, or we can call it as fuzzy logic. A fuzzy set we can call as an extension of the classical set. When I'm talking about classical set means what? A set in which every element either belongs to set or does not belongs to set. For example, if I take a set which is collection of all the presidents of India till now or till date, so it can easily identify that which one belongs to this set or which one not. Like if I take Mr. Narendra Modi, that he will not belongs to the set because he is not a president of India. Now, if I take some other name, like suppose that the Draupadi Murmu, currently she is the president of India, so she will belongs to the set. That means whatever individual we are talking about, either he belongs to the set or does not belongs to the set. So this is what we call as a classical set or binary set. Classical or binary set means what? A set which is having only two possibilities, either belongs to or does not belongs to. On the same time, when we see the example of surrounding to us, many times it's not the case that an individual belongs to your collection or does not belongs to your collection. That means the relation, that means the condition or the operation that we are talking is not binary in the nature. Binary means either yes or no. There are many scenarios when we need the extension of this thing. For example, suppose that I want to make a collection of all hot days of a city. Let us consider it as I am currently in Pune, so Pune. So collection of all the hot days in Pune. So now what happened? It vary from person to person. This collection will vary from person to person, as it may be there's an individual who feel if there's a temperature which is somewhat 35 degree, it should be considered as a hot day. But on the same side, there may be someone who say no, 35 is not a hot day, 37 or 38 degrees is a hot day. But on the same side, someone is there who feel hot at 30 degrees Celsius. So over here in this scenario, you can observe, you can see your collection varying from person to person point of view. As we know, a set is a well-defined collection of objects. Classical set definition, whatever individual is there, you are able to decide it belongs to your collection or not, then we call it as a set, well-defined collection. Over here, the concept is not well defined. We can call it as a fuzzy. We can call it as a fuzzy concept or fuzzy relation or fuzzy set. Okay, so in a fuzzy set, what happens in place of binary, we are talking about partial membership. We will talk about partial membership means what? If suppose that if suppose that we are saying that 40 degree is a hot day temperature, then what about 39.9 degree? What about 39 degree, 38 degree, 35 degree? Should I say that day will not belongs to your collection? The answer is no. The answer is for this question is what? Those day, if I'm taking 40 degree as a hot day, then 39.9 is also having almost same intensity of humidity or warmness. Okay, so that as per classical definition should not belongs to your collection, but fuzzy simplified this thing, and the concept of fuzzy set says that 39.9 degree should also belongs to your collection, but with a different membership value. Means if we add a thing which is called a membership value to a classical set, it converted into a fuzzy set. It converted into a fuzzy set. That means along with the individual, we are supposed to mention if this individual belongs to your collection, what is the degree of membership that this individual is having. That also called as the intensity of belongingness, like 39.9 degree belongs to your collection with intensity, I can say 0.95. When I'm talking about membership function, it's range like probability varying from 0 to 1. 1 means perfect membership, 0 means perfect non-membership. If the membership of an individual is 1, we will say it is perfectly belongs to your collection. If the membership of an individual is 0, we will say it will perfectly non-belonging to your collection. If somewhat between them, we call it as a partial membership function. Okay, so this is what exactly a fuzzy set is. A fuzzy set is having a membership value along with the individual, having variety of applications. For example, it is used in natural language processing (NLP). It is used in expert system. It is used in if I'm talking about mechanical point of view, it is used in reliability engineering, which is used to check whether or how much reliable a system is. In the same manner, we can say it is used in your cryptography also, where your collection is in place of classical, it is a fuzzy set. Okay, so these are the some of the applications that we are having, and this is what exactly a fuzzy set is. Now, to get the exact definition and some example based on it, let me share the screen. So in today's session, what I'm going to discuss, we will discuss the definition of fuzzy set, what is a membership function, and we'll take some of the examples. Yeah, if I want to give one more application of fuzzy set, you can consider like the smart washing machine is the example of fuzzy set. Regulator in your fan is also example of fuzzy set. How it is fuzzy set? Like if it is a switch, it is an example of a classical set, either on or off, binary, yes, no, right, wrong, 1, 0. But on the same time, when a regulator comes in the picture, then at the position 1 or point 1, we can't say the fan is not working. The fan is not working. We can't say fan is working with full efficiency or full capacity. So kind of fuzziness. The fan is working. Yes, it is working, but not perfectly working. It is working with some degree of fuzziness. On the point number 2, more belongingness. Point number 3, more belongingness. If there are only 5 points, at the point number 5, it is the perfect example of belongingness. Perfect belongingness will be there. The membership will be 1. It may be at point number 1, we can say 20% belongingness or 0.20 belongingness. So example of fuzzy set. Automatic cars, where manual transmission is not there, manual gear is not there. Earlier, what happened? Gear one, two, three, four, five kind of scenario is there. But nowadays, what happened? We are getting the automatic transmission. So only you are supposed to put at go, and the gear is shifted automatic behind the scene as per the speed of your car. Example of fuzzy set. Perfect example of fuzzy set. So wherever we having these kind of scenario, we can say this is related to your fuzzy set. Okay. Now moving to the definition, let us see what exactly a mathematical definition is there for fuzzy set. So fuzzy set is a collection of ordered pair which is defined as, so as a classical set is having only one individual which is either belongs to or does not belongs to. In fuzzy set, we are having a ordered pair, and ordered pair is defined like this: x comma mu ax, x comma mu ax. This x is called as individual. Individual means the member that we are talking about. It comes from your universal set or set of discourse, and this is what called as a membership function. This is called as a membership function. Okay, so as if I'm talking about a simple set or classical set, it looks like if we are having this, a collection of one, two, three. But on the same time, if I represent it in terms of fuzzy set, so it should be every element is having a ordered pair. Do remember, we are saying ordered pair. That means first one is the element, and second one is the degree of belongingness, the intensity of belongingness it is having. The individual X, how much intensity it is having to be the part of that collection. This is how we can understand as a fuzzy set. If I want to write it in terms of fuzzy set, it should be looks like this. Some membership value for one. Let it be one is having membership value 0.2. 2 is having membership value 0.5. 3 is having membership value as 0. Okay. So this is how, so this is your classical set, this is your fuzzy set. How it is decided 0.2, 0.3 or 0? That is based on the nature of your membership function, which is denoted as mu AX. Mu AX, A stand for the given collection. So capital X is your universal set and small x comes from there. So it called as a universe of discourse or universal set. And mu x we call as a membership function as already discussed. Now there are certain characteristics that a membership function is having. Let us try to talk them. One thing is what a membership function, as already told you, like probability, it always varying from 0 to 1. Its value is always from 0 to 1. So we can call it as a membership function is a function whose input comes from universal set and output comes from this set. This is what a part of real number, a interval from 0 to 1. Okay, so a membership function is a function which decides the membership value of the individual inside a group. It may be anything including 0 to 1. Now let us see some more characteristic for a membership function. As already discussed, it decides the intensity of a particular element, whether it belongs to the set or not. It represents the degree of membership of X with respect to a given set. It represents the degree of truthness. Like when I'm talking about binary, true, false, yes, no, 1, 0, there's something which is called as a degree of truthness. So a membership function is also used to decide the degree of truthness. How much it is true, 90%, 80%, 70%, 60%, or how much exactly. Okay, a membership value one represent as the complete belongingness as already discussed. A membership value 0 represent the complete not belongingness, or we can say that individual will not be the part of your fuzzy set. A membership value between anything to 0, 1 is called as a partial membership value or partial belongingness of an individual X inside or in your fuzzy set. Okay, so I hope you understand the definition as well as the nature of the membership function. There are a variety of membership function, standard inbuilt membership function in many computing tools like MATLAB, R, or something else. So we are having trapezoidal membership function, triangular, Gaussian, exponential. So they are inbuilt function in many tool, and as per your data need, the suitable membership function is supposed to be used to find exactly the fuzzy set along with their membership value. Okay, now let us move on. Let us take one example on it. So suppose I am having X, which is having individual 1, 2, 3, 4, 5, 6, 7, 8, be the universe of Discord, that is the universal set, and I am considering A as a set, the number is closer to 4. The collection of all those numbers, better to say, the collection of all those numbers which is closer to 4. Now, should I consider 3 is closer to 4? 2 is closer to 4, 5 is closer to 4, 6 is closer to 4, 7 or 8 or not? So once again, the rule is not well defined. Not well defined means fuzzy, vague in nature. So in this scenario, we are supposed to write in place of classical set, we will write a fuzzy set. And to write the fuzzy set, what we need the membership value. What will be the membership value of 1? The membership value of 2, 3, 4, 5, 6, 7, 8. So let us see. So then it can't be represented as a classical set, but we can represent it by fuzzy set. Let us see how it can be represented as fuzzy set. So for that, we are supposed to define some membership function or some membership value. Until unless we did not have some membership function or membership value, a fuzzy set can't be defined. Okay? So I'm just assuming something. Let the membership value as 1 of zero point 0.4, 2 is having zero point 0.6, 3 is having zero point 0.8, 4 is 0.1, 5 is 0.8. In the same manner, the other individual. The membership value of 8 is 0, means we are saying 8 is in no mean closer to 4. So this is how we can write the fuzzy set. So this is how the fuzzy set A will be represented. Individual X and their membership value. So we listed all the pair along with their membership value, and this we call as a fuzzy set. I hope now you clearly understand that what exactly a fuzzy set is, what is the role of the membership value inside it, and how we can write. Now, in this example, there's a one, I think, doubt is there in your mind that how I decided that membership of one is zero, membership of two is 6.6, and so on. That how this membership value is decided. The thing is that there are two kind of scenario. Either as per the given data, as per the given information, you are supposed to use some inbuilt membership function, as I already discussed, or if you feel like we are supposed to generate some new membership function, we can generate it, and on that basis, these values can be calculated. Okay, so now let us take one example where we will calculate the membership function as well as the membership value and then corresponding fuzzy set. So construction of membership function, then calculation of membership value, and then finally construction of fuzzy set for a given set of data. Let us move on to take one example on it. So the problem is what? Suppose that we are having some data set for our family members with their age and gender. So this is what we are having a data set. This family mem is having 8 members. Their age is given, their gender is given. Okay. Now let us see what else given. Find the following fuzzy set. We are supposed to find some fuzzy set. Let us see what fuzzy set they are asking. So set A, all senior members of the family. Set B, all young member of the family. Now, suppose that I'm interested to write all senior members of the family. So what did you think? Which should be there? Grandfather, grandmother, father, mother, uncle, auntie. In the same manner, young member, son, daughter, mother, or which should be there? So now here the rule which is defined is not classical, not binary. It is what a fuzzy kind of system. Here, it may be that I am feeling a person whose age is somewhat more than 70 can be considered as a as a senior member, or it may be I am considering anyone more than 65 is the senior member, or more than 60, 55. It vary from person to person individual. That means I need to decide some cutoffs and then we'll decide that what will be the membership function for this problem. So now either the cutoff will be given in the given data set along with the problem, or we are supposed to decide by using the common sense as per the given information or data. In this problem, it is given we are supposed to consider an individual whose age is greater than 70 as a senior member of family and the one whose age is less than equals to 45 year as a young member of the family. So this is given along with the problem. So we can use this information to construct the membership function and on that basis we will find the fuzzy set. Now, let us try to draw its graph, a membership graph, which is very much useful in construction of membership function. So on x-axis, I am taking the individual like grandfather, mother, father, son, daughter, uncle, auntie. And on second axis, I am taking the membership function. So we can call it as membership function mu ax. This is for A, all the senior members of the family. The cutoff is given at 70. So somewhat here, let I am taking it is 70 years. Okay, the membership function is already discussed will always from 0 to 1. So this is somewhere 0, this is somewhere 1. It is given the individual whose age is greater than 70 degree is considered as a young senior member of the family. So the individual which is having 70-year age will perfectly having membership value 1, perfectly belongingness. More than 70, like 75, 78, 100, everyone is having membership value as 1. What about on the lower side? On lower side, we are supposed to use another cutoff, which is 45 year. So let us make it somewhere over 45 year. What will happen with the individual whose age is 67 year? Yes, it will be there in your collection, but with a partial membership. So now the individual whose age is from 45 to 70 year will be there in your collection as a linear increment, or like this line gives the membership value for them. So 45 to 70, like the individual whose age is 46, it will belongs to your collection, but with a less membership value. Individual with 50, yes, but more than 45-year membership value, then 65, 67, and so on. What about less than 45? It will not belongs to your fuzzy set, the membership value is 0. So this is what I draw the membership curve or membership function graph, membership function curve or graph for all senior members. If you see, it is having 4 phases, or better to say 3 phases. 0 to 45, membership value is 0. 45 to 70, this line gives you the membership value, and 72 more, this is the membership value, which is 1. Okay, so I'm supposed to find the function for it. Let us see how we can find it. So make them as, suppose this is, so when we write the membership function for this function x, let us write like this. So there are two clearly mentioned phases. The first one, when x is greater than 70, when x is greater than 70, or we can write it greater equal to 70. So in this case, the membership function is 1. Membership function giving the value as 1. The second case is between 45 to 70. That means when your x is greater than 45 and less than 70. We can put equal on the 45, no problem. Then the curve, the value of membership function is given by this equation, and we didn't know till now what will be that is equation. The third one is what when less than 45. So when x is less than equals to 45, x is less than 45, we can write in this phase, the membership function is having value as 0. So your membership function is divided into 3 phases. One is 0 to 45, one is 45 to 70, one is more than 70. 0 to 45 and 70 to more directly comes out from the given membership graph or curve. But what about 45 to 70? If I make it as line A and this as point B, so the between value 45 to 70 can be calculated by the equation of line, which is AB. So I'm supposed to find equation of line AB, and I hope all of you know it. The equation of line passing through two given point. What is the coordinate of A? X comma Y, x-axis 45, y-axis 0. B, x-axis 70, y-axis 1. So we are supposed to find a equation of line which is passing through 45 comma 0 and 70 comma 1. Equation of line which is passing through 45, comma 0 and 70, comma 1. Equation of line passing through two given point is what? Y minus y1 is equals to y2 minus y1 upon x2 minus x1 into x minus x1. Equation of line in slope form. Let us consider this as x1, this as y1, this as x2, this as y2. You can consider anything like first pair, you can consider x2, y2. Second, you can consider x1, y1. There's no impact on this since we are finding an equation of line passing through two given points. So any point can be taken as first, any point can be taken as second. So put them in this line. So y minus y1 is 0, then y2 minus y1 upon x2 minus x1. So 70 minus 45 into x minus x1. So what I get from here, which is equals to y minus y0, y equals to x minus 45 over 70 minus 45 is how much? 25. So the membership function for the values which is in this range is calculated by x minus 45 upon 25. X minus 45 upon 25. Till now, what we did, we constructed a membership function. Okay. So membership function is constructed as per the given cutoff. Now the next thing is what? On the basis of this membership function, we are supposed to find the fuzzy set. So let us see how that fuzzy set will be constructed. So each individual is considered as the values of x. So let me rub this section so that we can write the fuzzy set on it. So each individual will be considered as a fuzzy element of your fuzzy set, and the membership value will be calculated on the basis of the membership function that we just constructed. Okay, so let us see what will be the structure of set A or how the set A will looks like. So A equals to the first individual is grandfather. So your grandfather will belongs to your set. Yes. What will be the membership value? The age is 75 years. So where 75 lies in the first section, greater than 70. So membership is 1. So grandfather, comma 1. The ordered pair, recall the definition. Ordered pair where first is individual, second is membership function. The second one is grandmother. The age of grandmother is 67. Now 67 lies in which domain? Not in first, not in third. In the second phase, it will lies. So in place of x, I'm supposed to put the value of x, which is what? The age. So I will put x as 67. So 67 minus 45 upon 25. How much it will be? 67 minus 45 divided by 25. It comes 0.88. So grandmother will be the part of this collection A with the membership value 0.88. Then after your grandmother, we are having father. The age of father is 51 years. So it will also lies in the second phase, 45 to 70. So put x equal to 51 in this equation. So 51 minus 45 upon 25. So which is 6 divided by 25. So 0.24. So the membership value for the father is 0.24. Now the membership value of mother. Mother is having age 46 degree, 46 years, sorry. To put 46 in the second phase, 46 minus 45. So 1 upon 25. So 1 divided by 25, membership value 0.04. Then the next individual is son. The age of son is 25. 25 is lies in the third category, less than 45, belonging as 0. So the membership value for son to be the part of your senior member of the family is 0. In the same manner, if we are talking about daughter, the age is 20. So yes, it is 0. Then uncle is having age 42. Yes, it will also 0. Then auntie is having the membership value age as 37. So lies in the third category. So 0. So this is what your fuzzy set A. I hope you understand it, that how I constructed the membership function, and on that basis how I get the fuzzy set. For any confusion, do back and see it once again. Now, talking about the example part number two, and here what they're asking the one who's we can call them as a young member of the family. Young member of the family cutoff is the same thing, but we'll get the a different membership function. How that membership function looks like, let us try to generate it. So on the same side, this is your X, this is your mu B. We are considering as a membership for B. This is 1, this is 0. Cutoff is same, 45 and 70. Okay, let us see how we will write it. The individual whose age is less than 45 is belong to your all young member with the degree of membership 1. So everyone from 0 to 1 is having membership as 1. 0 to 45, membership is 1. More than 70, membership is 0. That is the senior collection. And between 45 to 70, a line of equation which looks like this. So between 45 to 70, the membership function or the membership value is calculated from this equation of line. In the same manner as we did in the last question, so now the membership function, which is mu bx, will be written as once again three phases. When x is less than equals to 45, the membership is perfectly 1. When x is between 45 to 70, greater than 45, less than equals to 70, we will calculate by the equation of line. The third one is greater than 70, it is 0. This equality can be put it anywhere. Do not get confused. I have put it equal to here, not here. I put it equal to here, not here. You can put it here. No problem with it. Okay. Now the membership function for the second phase. The coordinate of this point is 45, comma 1. X-axis 45, y-axis 1. This is 70 cross 0. So for the second phase, I am supposed to find the equation of line which is passes through 45, comma 1 and 70, comma 0. The equation of line will be as earlier y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1. Consider it as x1, y1, x2, y2. Okay, so y minus y1, so y minus 1 equals to y2 minus y1. So 0 minus 1, x2 minus x1, so 70 minus 45 into x minus x1. So it gives you y minus y1 is equals to, so this is minus sign, take it inside. So 45 minus x, 70 minus 45 is 25. Take this plus 1 on that side. So 45 minus x upon 25 plus 1. Take the LCM. So y equals to 25. 45 minus x plus 25 upon 25. 45 minus 25 is 20. So 20 minus x upon 25. This is the equation of line that we get for the center values or the second values of x. So 20 minus x upon 25. Okay, we can reverse it like this gives you much calculation. So in place of writing this, we can write the point 70, 0 and 45, comma 1. So that the calculation will become easier. Let us see how. So x1, y1, x2, y2, y minus y1 equals to y2 minus y1 upon x2 minus x1 into x minus x1. X minus x1. So your x minus x1 is this one. So in this manner, we can also calculate the equation. Okay, so we are supposed to find the equation. Okay, so x minus 70, and if I simplify, x minus 70 upon 45 minus 20, 70 is 25 with minus sign. Take minus outside, so 70 minus x upon 25. Oh, why I'm getting it 20 minus x? Oh, this is 45 plus 25. So yes, it is also 70. So 70 minus x upon 25. So you can see in this phase, I need to do a lot of calculation, but it is solved within 2 steps. Okay, so choose wisely the points so that we get equation of line easily. Even in both the manner, you are getting equation of line. Okay, so now the membership function is constructed for set B also. Now, why I'm constructing the membership function? To calculate the set B, fuzzy set B. Okay, so now fuzzy set B will be calculated as how? Let us move back. The first one is grandfather. The grandfather is having age 75. 75 lies in the third category. So the membership function for the grandfather gives you the value as 0. Let me rub it so that we can write the fuzzy set B over here also. Okay. So now fuzzy set B, the first one is grandfather. So grandfather is having age 75, lies in this domain. So membership value 0. Then we are having grandmother. The age of grandmother, let us see back, 67 year. 67 year lies in the second domain. Okay, so 70 minus 67, put it over here, like 70 minus 67 upon 25. So 3 upon 25, 3 divided by 25, 0.12. So this is for your grandmother. Then the third one is father is having age as 51. Father, the age is 51 once again lies in this domain 41 to 70. So 70 minus 51 is 19. So 19 divided by 25, 0.76. So this is for father. In the same manner, mother is of 46-year-old. So now is mother is 46-year-old, also in the second domain. 70 minus 46, so 14 upon 25. 14 divided by 25, so 0.56. In the same manner, after mother, we are having son whose age is 25. So son, 25 means lies in the first domain, so membership is 1. Then after son, we are having daughter, age 20. So daughter is having 20 in the same manner, lies in the first phase. Then we are having after daughter, uncle 42. So uncle 42, 42 means in the first phase, so 1. And then auntie is having age of 37. So 37 will also lies in this phase. So yes. So this is how we constructed fuzzy set for B. So in this example, what we did as per the given information, as per the given data, the cutoff is also given. Firstly, we decide the try to draw the membership curve, and on the basis of membership curve, a membership function is generated, and that membership function is used to find the membership value for every individual in the data set. And then finally, the fuzzy set, as already discussed, a collection of ordered pair. The first one is individual and the second one is the membership value. I hope you understand this example. There's one more example on it. Kind of salary is given. Then we are supposed to find the fuzzy set for all A, all employees having high salary class. B, all employees having low salary. Cutoff is also given. greater than 9.5 lakhs or 9 lakh 50,000 is high salary, 2.50,000 is low class salary. So now we can construct the fuzzy set as in the same manner as the last example. So firstly construct the membership function and then fuzzy set. So how the membership function looks like for mu A. Cutoff is 9.5 and 2.5. So in place of writing the complete number, I am writing 2.5 lakhs. 2 lakh 50,000 and 9.5 lakhs means 9 lakh 50,000. You can write the complete number, no problem with it. So firstly, we are making for A, so 0 to 1. So 9.5 and more than this is having membership value as 1. Between this, the curve equation, below this, 0. The coordinate for this point is 2.5 comma 0. This is 9.5 comma 0. Now calculate this equation line. How the membership function will looks like for this? Less than 2.5 lakh, it is 0, this phase, and then 2.5 to 9.5, we will calculate by this line as in the same manner as the last example, and then greater than 9.5 is 1. So this is what membership function will obtain. Use this membership function to write fuzzy set in terms of membership value. In the same manner, if I'm talking about membership function for the lower class, so cutoff is same. So 2.5, 9.5. This is your mu bx from 0 to 1. 2.5 less than 2.5, perfect 1. 2.5 to 9.5 given by this curve. More than this will be 0. So the membership function for this curve will looks like when x is less than 2.5 lakh, the membership is 1. When x is greater than 2.5 and less than 9.5, it is given by the equation of this line. And when x is greater than equal to 9.5, it is 0. So this is how we can generate the membership function for this problem. And on the basis of membership function, the fuzzy set A as well as fuzzy set B can be easily generated. Try to complete it by yourself. So this is how we simply generated the fuzzy set as per the given information, as per the given data. Important of membership function, how we constructed, how to use to generate fuzzy set. Okay, there are variety of application for this specific topic. Try to explore this. For this session, that's all from my side. Let us close it.